All right, first, thanks for staying. And for those that aren't staying, thanks for staying that long. It's fine. I'm not offended. I'd ask, we've been here a long time. Can everyone just stand up and stretch? Because I feel a lot of people here yawning and getting tired, and we all kind of need a little, just don't leave, but like stretch, enjoy yourself. Okay. That felt good, didn't it? That's good. All right. All right. So I'm going to talk to you about what's honestly probably my most personal talk I've ever given. It's 7 common mistakes in Go and when to avoid them. Francesca introduced me working at Docker. I've also written a number of libraries and tools in Go. And the reason I highlight them is because I'm actually going to talk about, these aren't common mistakes, these are my common mistakes that I've made in Go, and I've seen in other things, and maybe you're making them too. All right, so how do you feel when you see that? Does anyone else experience a bit of pain? We've been conditioned in this country, and maybe a lot of countries, from when we're very young, that failure is a bad thing, and that we shouldn't fail, and it experiences pain and anguish whenever we see something like this. And it's because it's so deeply ingrained in who we are that failure is something that should be avoided at all costs. This is a quote. It's might as well be from Yoda. It's not, but it says, "Do you want to know the difference between a master and a beginner? The master has failed more times than the beginner has tried." And Ed Catmull, founder of Pixar, said, "We need to think about failure differently. Most people think mistakes are a necessary evil. Mistakes aren't a necessary evil. They aren't evil at all. They are an inevitable consequence of doing something new, and as such should be seen as valuable." Right? Go is a new language, relatively speaking. I think a lot of us are trying to do new things with it. Consequently, we're going to make mistakes. I personally make lots of mistakes, and there's a human tendency to want to cover up our mistakes and not to broadcast them. And I'm completely fighting that human tendency as I share my mistakes with YouTube and all of you in this room and anyone who watches this video later. So, do we know who this is? It's also someone else. His name is Michael Bluth from a TV show Arrested Development. And if you watch this show, you generally relate to this character because he doesn't want to make mistakes. There's another character who makes huge mistakes, who we laugh at and don't find as relatable. And hopefully by the you'll see kind of a contrast here. So the first mistake, and a lot of these are related to first, every one of these mistakes are Go specific. They're not general programming mistakes. They're part of the language. Most of them have to do with what I think are the two biggest new features. One is concurrency and the other one is interfaces, which yes, some exist in other languages, but the way Go does them is unique. So the first one is not accepting interfaces. Now, I think it's important, and this is, I know this room's pretty Go savvy, but it's important to recognize that there's state and behavior, and these are two fundamental principles of computer programming. Types in Go can express both state and behavior. State is equal to the data structure, and behavior equals the methods. Interfaces are one of Go's most powerful features. They permit extensibility. They're defined by methods, meaning that Go interfaces are behavioral only. The adherence is satisfied only by behavior, not at all by the data structure, not at all by the state. So I want to use an example from Hugo. If you haven't heard of Hugo, it's the fastest static site generator there is. Just a little story about this. We got a bug report, I don't know, 6 months ago. Someone was trying to build something with like 15,000 posts. And they said they tried every static site generator that there was. Most of them didn't ever finish. Hours later, had never finished. Most crashed. One finished in an hour and a half. Hugo finished in 10 seconds. So it's fast. Now, most people also don't have 15,000 posts, but if it can do that in 10 seconds, it can compile your blog a lot faster than that. And so this is all code examples from code that mostly I wrote. So first one is don't do this. So what are we trying to do here? First, just setting up the stage in this slide, we've defined a new byte buffer and we're writing to it. There's nothing wrong with that specific part. But the next thing, what are we doing? We're grabbing the bytes and we're passing them into another function. And the signature of that function here that only accepts a byte slice. And what does that do? Well, it creates a new reader. Right? So we've gone from something that satisfied a reader to extracting the bytes to creating another reader from. Right? And you look at that and it seems pretty obvious, but if you look around Go code, you'll see things like this. It's not just in my code. It's in a lot of other people's code too. So instead, right, what's the solution? It's pretty obvious here. All we do is convert it. Instead of taking a byte array, we're going to convert it to take an IO reader. And in doing that, we're taking an interface instead of a specific data type. And it's a lot more efficient. So mistake number 2 is piggybacking on that. It's not using IO reader and IO writer. And it's, if you look around different libraries, it's amazing how often this is not happening. So what are IO reader and IO writer? They're simple and flexible interfaces for many operations around input and output. They provide access to a huge wealth of functionality, and I really want to underscore how much you can do with these two things. And they keep operations very extensible, and they're really simple. I mean, you can't define simpler interfaces than these. And light of time, you can read it, but the reader has a read method. That's the behavior it expects, and the writer has a write method, and that's the behavior it expects. So here's an example from Cobra CLI Commander, which powers Kubernetes and Hugo. And so this line is actually one of the most powerful lines in the entire program. What this does is it lets you, for each command, like a command is like git clone, and clone would be the command. It lets you define a specific output for that. Because we've enabled it to be IO writer, it accepts a whole slew of different outputs, logging systems, network layers. There's a whole lot of different things you can do. In this case, we default to OS standard error, which again adheres to that same interface. Viper is another tool. It's kind of the companion to Cobra. It lets you do configuration management, so it automatically reads JSON and TOML and YAML files and environment variables and remote key value stores. And this is right from that code. This is actually from a pull request. I didn't write this one, but it was a great learning experience. So someone contributed this, read buffer config, and they passed in buff bytes buffer. Right? There's nothing wrong with this code. This code runs fine. It works really well, but it's very prescriptive about what's going to happen. Right? Much better is to define it as an IO reader, which bytes buffer adheres to. It adheres to that interface. When we do this, it enables our code to be much more extensible. Now people can pass a whole lot of different things into this, whereas before we were very prescriptive. By the way, for me, if you have a question, just shout it out. Well, I don't know, raise your hand or something, but I don't want to wait till the end and then you forgot it. So I'm assuming no one's had questions yet. All right. I think a lot of this, I think it's obvious when you look at the slides. Hopefully you also think it's obvious. When you're writing the code, maybe it's not as obvious. So third one is, requiring broad interfaces. So interfaces are composable. Functions should only accept interfaces that require the methods that they need. Functions should not accept a broad interface when a narrow one would work. You can compose broad interfaces made up from narrow ones. So use a couple examples. This is a Pharaoh FS. It's a library that I wrote specifically to make it so I could do testing better. Because with Hugo, we do lots of creating sites and then destroying them throughout the tests. I didn't want to write to the file system, but I didn't want to rewrite my code. So luckily, because the OS package defines all these interfaces really well, I was able to write a really thin library that lets you do neat things. Specifically, it gives you cross-platform memory-backed file system that's completely interchangeable with the OS package. And so what do we do inside this? I've defined a file interface, and it has a whole lot of different interfaces that it's composed of. And it's tempting when you're defining a function throughout all this to say, hey, I'm going to include that broad interface. I'm going to include file everywhere, right? And if you've used other languages, a lot of other languages, it's kind of actually a pattern you look for. In Go, we don't want to do this. Why don't we want to do this? Why limit yourself? Well, what if I don't want to implement the entire file because I have good reasons not to, right? But now I can't use this anymore. So much better, we're only using the read function, so we should only use the reader interface. We shouldn't use that broad interface. All right, mistake 4, methods versus functions. I know this one trips up a lot of people, and it did me a lot when I first started. So how many people come from an object-oriented background? Really, what do the rest of you come from? Like, I know Robert doesn't, but I don't. Some of you just don't raise your hands, I guess. Right, and we've learned that. We've been ingrained with that. A lot of us, that was the first programming environment that we really learned. And so we've been ingrained in how to use it. And part of that is, it's a lot really method heavy. And there's a natural draw for object-oriented programmers to define everything via structs and methods. But what is a function? So let's kind of define it. A function is operations performed on n number of inputs result on n number of outputs. The same inputs will always result in the same outputs. So functions don't depend on state. That's how they can adhere to that. What is a method? Method defines the behavior of a type. This is very specific. All right, so remember, it goes back to the whole interface being behaviors. It defines the behavior of a type. A function it's a function that operates against a specific value, and it should use state. The whole point of it is to use state, and it needs to be logically connected with that state. And functions can be used with interfaces. So method, by definition, are bound to a specific type, whereas functions can accept interfaces as input. So example from Hugo, and this is an example of one that I think is really, Page is a major data structure within Hugo because it creates websites, so it creates lots of pages, and there's tons of methods on it, and there's a big draw to put everything down as a method. And initially when I wrote this function, shortcodes are kind of like template macros. And there's a draw to make this a method as well. And when I started, it was a method. And I looked at it, I thought, why is this a method? It's not actually doing anything with that. It's using it, but it's using it as input. The same input, the same page every time, will always result in the same output. It's not manipulating that page. And does that make sense? Am I explaining that reasonably well? A lot of people are nodding. Wow. That means you're even listening and paying attention. This is going pretty well for 9 at night. Right, so if you look here, we're really not manipulating it at all. We're just using it as if it was input.
But then you've got to decide which of those things on page are exported, returned. I mean, I'm not saying I like this pattern, but just you have to think about that.
Shouldn't you be thinking about what's exported and not? Yes, you're right. You're totally right. Your point is valid.
When extract shortcodes is not in the same package, you might be you need access to stuff like you're accessing an unexport and an export. It's just right?
That's a very valid point. Yeah.
So why would you not think of that the shortcodes as a bit of the state of the page and say this is just a getter of that state?
So to repeat, the question is, why would you not consider it something about the state with the page? It certainly is part of that, right? And you could make an argument to do this, to make it a method. The fact is, it's not changing that state at all, right? It's using its state. It's also using the string as input. So it's using multiple things as input here. The fact is, by definition, it's a function because the inputs and outputs, given the same inputs and the same outputs, it's always the same. Methods don't do that. Methods take inputs, often will change the state and result in an output. Maybe it's the same output, but that state change is going to be the difference. Now, you can include it, right? There's not a hard set rule not to include it. And sometimes logically it makes sense to group things together around something. And often, in Go, a nice thing is you can actually have an empty struct or even a nil, and you can create methods on those things, right? But typically those are for logical groupings rather than treating them as methods. So really they're acting more as functions in that result. So mistake 5 is pointers versus values. So I've heard a lot of people, when I was learning Go, I heard a lot of people say, always use pointers, they're so much faster. Or always use values because maybe that's where they came from, right? If they came from a language like Java, they want to always use values because they want to copy everything. It's not generally a question of performance, but it's one of shared access. If you want to share the value with a function or method, then use a pointer. If you don't want to share it, then use a value, right? So generally, performance isn't the thing you should worry about. It should be about access and how you want to use it. So pointers versus value receivers, this is another question I get a lot. I see a lot of people don't know what to do. A lot of the default answers, always use the top one. That's what generally people say because it's usually right. But again, pointer receivers are good when you want to share values. And often with methods you do. And because methods are manipulating things, so that's a very common thing. Remember, these are not safe for concurrent access, right? Because they're also using shared. Then you got value receivers. If you want the value copied, then you use values. If the type is an empty struct, right, so there's no value to it, again, you should use values. And these are safe for concurrent access. So another example from a Pharaoh. In this case, right, we're calling close on a file. Right? Why would we want that shared? Right? Were you sending a pointer? Why? It seems because we modified state. That's exactly why. And we want that universally modified. Another example. This is from the time package. Right? In the time package, it does use it uses methods, but it uses them on values, not on pointers. Why would it want to do that? Anyone?
Time's ticking.
Because time is ticking. Yeah, that's really. This one should be obvious. Boy, thank you for being the brave person to shout out an answer. Okay.
It's taking a little while.
Yeah. Yeah, time was ticking. Ooh. All right. So mistake 6, thinking of errors as strings. So when I started learning Go, all I heard about was all these complaints about errors and how Go handled errors. And I think with all these conversations, people completely missed the point of what Go errors are and how powerful they can be. Yes, you don't throw them, but you can do a lot of things with them. So first, a lot of people when they learn Go are surprised to find out that error is not a type. What is error? It's an interface. It's a very simple interface. It's an interface that has only one behavior defined on it. It has an error method that returns a string. All right, so you can do a lot with that. So first, the standard errors are often sufficient. Right, so you can call error new and provide a string, and it will create a value of type error of interface that adheres to the interface error. You can also export error variables that can be easily checked. So from Hugo, this was some code in Hugo. We created error new, and we gave pretty standard error there. All right, this is fine, it works, but how do you compare that? Usually people result in string comparison. And that's generally not the best way to do things. So better is to export it with a variable, and now we can check values, right? Checking values is a lot better than checking strings. I see this in code all over the place, though. People are always checking strings or substrings to do it. This is another example of actually just the check. So that's the second part to that side. Now you can create your own custom error types. And there's 3 different reasons to do this. One is you can provide context to guarantee consistent feedback. Right? I see a lot of people creating errors that have lots of complex formatting in them. Don't do that. I'll show a better example. You can provide a type which can be different from the error value. Right? So the error doesn't, the error value and its own type can be 2 different things, and it's important, and you can do lots of powerful things with that. Last is you can provide dynamic values based on internal error state. So this is an example from Docker. Does everyone know what Docker is? Raise your hand if you don't know what Docker is. Well, I got you on that one, didn't I? You were excited.
I use it.
Yeah, it's good.
Brag,
All right, so this is from Docker, and this is a pull request we got recently. So Docker is a complex program, and we're trying to expand our errors and give better errors, and we're trying to prepare for internationalization in the future. At least someone who sent the pull request is. And so what we've done here is they've created this custom error type, which has error code and a message. Right? The message, if you look at error, right? What is this is how it adheres to the function. What is it doing? It's going to it has both the error code and the string representation of the message. The nice thing is you can check just the code. You don't have to look at the string message when you're using this. That allows you to do internationalization or various translations that the message value can be different from the code itself. From the Go standard library, there's some really good examples. So this is one. These are just standard errors at the top two line, and I cite them because it's important for the next slide. In this case, this is from the OS package. There's path error. And that's a very explicit type. And if you look at the signature here, or the definition of it, what does it have? It has operation, it's got a path, and it's got an error. And then look at how it creates it. It does the formatting for you in the error function. Right? So when you create this error, you're going to create it giving it 3 explicit things, and it's going to automatically format it for you. Now this is a function from inside the OS package. It's the write at one, and it returns an error. Right? And remember, error is an interface. So the first thing it does is it returns a standard error. Right? If f is nil, return a standard error invalid, which is a standard error. But if it's longer than that, it actually, and certain conditions happen, you're going to want to return a path error. Right? Path error is this explicit error type that we've defined earlier. What we're doing here is we're giving it the 3 parameters that we need to. We're not worrying about string formatting. Beyond that, you can do some pretty powerful things. So in this case, this is a fake function that doesn't exist. But what we're conceiving of here is you might be writing something and say, you know what? If there's a path error, I actually don't care. I want to continue. I want to do something. Right? I don't care what the path error is. There might be 4 different values for path error. I don't care which one it is. I just want to see any path error. I'm going to handle it one way. Otherwise, I'm going to fail. And I'm going to call it fatal. Another example here is this is a similar thing. We're checking the type. If the type's a certain thing, we're going to be fine with it. In this case, we're actually checking for the specific value there too. Right? So you can do a lot of things by checking with the types. Remember, the type can be independent of the error value itself. And that gives you a lot of power with errors. So they're a lot more than just strings. All right, mistake 7 is to be safe or not to be. First, you can't make everyone happy. You aren't a jar of Nutella. All right, so consider concurrency. If you provide a library, someone will use it concurrently. Here, it's going to happen. All right, data structures in Go are generally not safe for concurrent access. And values aren't safe. You need to create safe behavior around them. All right, so how do you make things safe? We just went through a lot of that with Aaron's talk, so I won't dwell on that. So with the Pharaoh, we were trying to map exactly the file system in OS. So this is how it looked initially when I coded it, and it worked really well until somebody put it in a Go routine. And when they ran a bunch of things concurrently, it blew up. Why did it blow up? Because it was trying to access the same thing at the same time. So what's the solution? It's a simple solution. It's to use mutexes and add some locks around it. Right? And for this, all right, that's pretty clear there. Now, why do you want to keep things unsafe? Right? I gave the presentation earlier, and this section I got a ton of feedback on. It was mostly constructive. I had made a mistake. So this is me trying to improve on that. Reality is there's lots of reasons to keep things unsafe. Safety comes at a cost. It also imposes behaviors on a consumer. Right? So if we look, if we define a proper API, it allows the consumers to add safety as they need it. And it lets consumers choose how they want to do it. They can use channels or they can use mutexes, whatever fits their situation. So this is back to the same slide. Why do we do it this way? Why do we put our lock in here? Because that's what the OS package does work concurrently, right? Because it delays things to the operating system, which lets things run concurrently. So we wanted to model that behavior, right? So we didn't let it define above it, because in this case it made a lot of sense to implement it here because it's consistent with the OS package. However, maps, which are part of Go, are unsafe by design. Right? Often safety is unnecessary. I believe that's the argument for why they're still that way. It enables consumers to implement safety as needed. Right? So I just showed an example. We're using a map. How do we implement it? We used locks around it with mutexes. And the consumer of that can choose how they want to implement the safety. I also have, which I'm not going to go through because of time and because we just had a bunch of stuff on channels, but you could also use channels to do this. All right, so the biggest mistake is not making mistakes. All right, so again from Ed Catmull, failure is a manifestation of learning and exploring. If you aren't experiencing failure, then you are making a far worse mistake. you're being driven by the desire to avoid it. And it takes me back to now, who do I want to be more like? I want to be more like Job and a little less like Michael, who makes a huge mistake. And that's my talk. Thank you.
So again, we have time for like 1, 2 questions. Yeah.
Great, yeah, I want to go back to a couple of these. One was the overly broad interfaces or concrete types instead of interfaces. And then the other was formal versus value receivers. It seems like both of those, or all of those, are being caught through tools. And I'm wondering if you see that actually happening.
Certainly GoVet and other tools like that could help with a lot of these things. And in fact, I think GoVet does help with some of these things. Reality is, the reason I think a lot of these, that I want to highlight them, is A, they're not obvious. I don't think they're always obvious. B, a lot of them, it's not obvious when to do it, right? Sometimes there's a good reason to do one, and sometimes a good reason to do it the other way. And there's a lot of context involved with that the code tooling couldn't help with, because it's not going to know enough about the context of how you're using it, kind of the architecture that you have behind it. And again, these are things that I saw myself do wrong, and I use a lot of libraries out there, and I see it. It's being confused in a lot of places. I think the reason it's confused is it can be confusing because there's not always a clear answer. So I think yes, it can help with some things. On the other side, I think education and experience of using the tools more. I think how much I've learned in the couple of years I've been writing Go, and as I look through the standard libraries, which I use as inspiration on things, I see differences over the ones that are created later, right? I think even the Go team is still learning a little bit about how this language works and how best to utilize it. And at least Andrew's nodding his head, so and so is Rob, and so is Robert. So I think this is their creation, but just because your creation doesn't mean you know everything about it. I think all of us are starting to explore kind of the different ways to do things in it. And the nice thing with a language that's so flexible in the way that it is, it lets you express yourself in different ways. We're all still learning. So, all right.
Okay, so if there's no more questions, thank you so much to all the speakers. Round of applause for all of them.